Excuse me. Let's talk a little bit about setting up domains and what this actually means. Domains are just rules for how you input data as far as attributes go on a feature class. They prevent typing errors, and they allow you to test to make sure that you put things in the right ranges or you select from the right options. And you can create them for an entire database, and they can be reused for different features within it. So if, for example, you have all this road or sewer or water line information, you can set all that up in the database, and then as you create files in the database, you can simply apply these rules, and it makes it seamless and accurate data entry. So we have two types of domains: coded domains and range domains. Coded domains is where you have a simple numeric code that corresponds to a longer written, more easily to screw up input. For example, the information you want to store would be the size of the water pipe. And the options that you have, because this is the only sizes you use in your community, is 1, 3, 6, or 12 inch. But you want them all formatted correctly: 1 inch, 3 inch, 6 inch, 12 inch, etc. You don't want to worry about misspells and typos and extra spaces or leaving out dashes and all that kind of stuff. You can set up coded domains so that you just use 1, 3, 6, or 12, and that's the only options you have. If you mistakenly try to hit 4, well, it just doesn't work. Plus, with coded domains, you basically get the drop down and you pick. Range domains are similar in that you set the types and all that sort of stuff, and then you have this minimum to maximum value, and whatever you type in has to fit within that, and if it doesn't, it'll take it. But when you're done and you run some tests to see how things work, it'll show you that there's some things outside the range, and then it'll flag them to be fixed. So this allows you to save spaces because the code is easier and shorter and quicker to store. But you set up the domain because while you only want to put in a code 12 for heavy industrial, you also need to know what heavy industrial means. And so it allows you the best of both worlds. By setting it up once, it saves you on all the data entry, yet gives you all the interpretation. How do you add coded domains? Simply go in the Domains tab in the Database Properties and enter the name, set up the type, set up the policies, and go on through. Price will, in the tutorial, walk you through a lot of this. Adding a range domain, same kind of setup. Enter the name, set up the domain type and the field type, minimum and maximum values, split and merge policies, and then leave the code value blank. You want to make sure you click apply after you do each of these steps when you're working on domains, and here's why. Say you set up 25 domains and something's wrong and you don't know which one. You're probably going to have to go back and redo all of them. After you set up each one, you want to click apply or OK and see if that everything goes okay to make sure there's no mistakes. That'll save you some heartache and grief sometimes. Assigning domains. You can assign domains to one or more fields. They may be assigned when a field is created or later. Domains must be assigned to fields of the same type, so you can't take a short integer and assign it to a long or a float to a double. They have to go with the same type. If you assign a domain to a field, you have to do it in catalog. Click the domain box and then select the properties, and you can go on from there. How do they work? Domains are most visible when you edit things. Coded domains are fields in the table of contents. They basically just have a drop-down box, and so instead of you typing everything in, you simply select stuff, and so that turns out to be a big help. Range domains, again, like I said earlier, you can put values in that are outside the range, but as soon as you do a validation, it's going to say, whoa, hey, something's wrong with that, you knucklehead, and then you have to go fix it. How do you edit coded domains? Coded domains show up as drop-down boxes. You can simply select the desired values, and if you forget to enter the description, and you can choose the form. It'll basically, if you don't do it when you set it up, it'll be blank. But again, the editing tools and everything there. Follow through the tutorials in this chapter, and Price will walk you through all these steps, and she'll do a much better job than what I am of showing you how to do this as opposed to telling you what it is. Again, editing, validate. If you have domains and ranges and this sort of stuff in place in your geodatabase, validating looks at those required things that you've put in there, and it lets you know when something is not right, and it flags those for editing to make you go back and say, okay, what's wrong here? Split and merge policies. What happens when you cut things up or add things together? When polygons are split into pieces or merged together to make a single new polygon, the attributes have to be updated. Depending on the type of attribute, different treatments are appropriate. For some things, you just simply copy what was in the old one into the new one. Sometimes you leave it blank. Sometimes you can divide the value up based on area. So if you split a polygon and you've got a population value and you put 40% in one polygon and 60% in the other, you can simply divide the population numbers up 60-40. Split and merge policies control the behaviors of the feature's attributes when the feature is merged or split. If you assign these policies, it will dictate how it does these things. It can save the tedious re-entry of every attribute or prevent inappropriate assignment of data. So if you know certain things need to always be shared when split, or proportioned when split, or left blank when split, you can assign that into the rules. Same way with merging. If when merging you're going to keep one over the other, keep neither, or whatever you're going to do, you can set that stuff up, and that actually will save you a lot of data entry. Merge policies reduce data entry tasks when features are changed. Lots of different ways you can do it. You can take weighted averages, you can add stuff up. There's different things. And the important part is to make sure that you set these policies before you do any of these things if you want to get the full utility of a geodatabase. And this is just some examples of showing how you can put the things together. You got polygon 9, and you're adding merging it with another piece, and so now you get this new polygon, and the zoning stays the same, the area changes, the value changes, the parcel ID is left blank. It's still a polygon, and it keeps the FID of the original object because it merged something into it. This is one example of how you could set things up based on these rules. Split policies work very similar. Split policies, for example, if you split a forest stand, if it's a cover type, it's probably not going to change. If it's board feet of timber that you expect to be in a polygon and you split it in half, you can allocate that based on area. If it's an ownership thing, you can default it to the original owner, or maybe you want to leave it blank because the only reason you're splitting it's because you're selling part of it. Split policies also reduce data entry when features are changed. Split policies are really good for preventing things like duplicates, geometric ratios, and you can also set up default stuff as well. And this is just an example, just like before, of how you take the one thing and you split it up, and you can see how the value is divided out, the zoning carries over, the area is divided up, the parcel ID stays the same, but now it's in two parts, becoming a multi-part feature. Let's talk a little bit about subtypes. Again, subtypes. What are What are subtypes? Well, they're integer-coded classes of features within a single feature class. Subtypes are based on a short integer field in a table that stores a numeric code. A description is added for display and interpretation and is what the user sees. In other words, you're going to create this massive network of roads. It's all a single feature class. You want a way to differentiate between the different types of roads. You could make them different domains, but that's really not what they are. They're still just roads. They're just different types of roads. Subtypes will allow you to enter a simple numeric value for a type of road, like a 1, a 2, a 3, or a 4. And that would then relate to a particular type of road that could be displayed differently or shown on a map differently, if you will. And that's basically what subtypes are used for. Using the default attributes automatically assigns the default values as features are added during editing and digitizing. So if you want it to always have certain properties, you can put that in and then change it as necessary. There are some advantages to subtypes. Each subtype can have its own default values. So the moment you select it's this kind of road or that kind of road, this kind of pipe or that kind of pipe, it can automatically populate the attributes relative to that type. Each subtype is treated as a separate layer. When you go editing, you can just edit the one subtype and not have to change any of the others, and it will then update the attribute tables and the features relative to those changes. Each subtype can have its own validation rules, so the effects of domains and connectivity can be independent of other subtypes. And effectively, each subtype can have its own topology rules. So what are some of the defaults, for example? Different default values can be specified for each subtype. This saves a lot of time in editing because it just automatically populates it, although there may be exceptions to the defaults. For example, old subdivisions have lead sewer laterals. If you need to go in and change that, you can, but overall, the amount of editing that you have to do would be significantly reduced in this example. You have the various attributes like pipe diameter, pipe material, maximum flow for water mains, laterals, sewer mains, and sewer laterals. And you can simply set up those defaults. Now, when you go out and you map something and you add it in and say, oh yeah, we found another sewer lateral, it's at such and such a location, it goes from here to here. You go into GIS, you make the thing up. Well, it's a sewer lateral, it's automatically going to tell it it's 6-inch pipe, PVC, maximum flow is 230. You can then go in and edit and say, oh, actually this is from an older subdivision, it's lead, not PVC. Okay, simple enough. When you edit, each subtype is treated as a separate layer. When a feature is added, it automatically takes on the default type of the subtype. So if you add in a sewer lateral, it adopts all that stuff that you've pre-set up for sewer laterals. When do we use subtypes? When do we use subtypes? When a feature class has a limited number of clearly delineated types. In other words, when it will save you a lot of time. When setting different defaults for each type is useful. In other words, if all your different water pipes were all 6-inch copper, what's the point? Set one default 6-inch copper for everything and just go. When the topological or network behavior of each type is different, subtypes become important. So if, for example, you're looking at flow rate or pressure, then the size of the pipe makes a big difference. So you could, for example, make a very strong case that that's the time when you need to use subtypes, so that when you put in these water lines, you can say this is a main, this is a lateral, this is a whatever, and it would then load up the subtypes that you've already set up, because that's what you select, and all those clearly differentiated types and all those unique defaults would all go in place, save you a ton of editing, and make everything topologically sound. So if you're going to do this, how do you do this? Step 1, plan your subtypes. First, plan. Establish the following properties of the feature classes. What subtypes will be used? Are they complete? Figure out what the attributes are for the feature class and domains that are going to be used. Come up with your split and merge policies for every attribute and your default values for each subtype as applicable. In other words, you have to sit down and spend some time thinking about this. You can't just do this willy-nilly on the fly off the cuff. It has to be something that is thought out and planned out so that before you ever create a single line on a map, that you already know that there's only certain numbers of options for the line that you're drawing, and that you've already got all that pre-established in your database. Subtypes for a waterline feature class: water mains, water laterals, sewer mains, sewer laterals. These are the kind of things we're looking at. Attributes and domains for water lines. If we look at the attributes for the feature class itself: pipe diameter, pipe material, install date, maximum flow. Some of the stuff, the domains that we have in the geodatabase would be things like the diameter, which is coded and you simply put in the number, or the material, where you simply put in the particular code for that. And then there might be a situation where you can set the flow range by simply putting in the number. And that's how this could look differently. The second step would be to create the various domains, where you go into the properties and you create them. And remember, as you're setting this stuff up, you want to do this after each step. So if you make a mistake, you can, it's the last one that you did, so you can fix it instead of having to go back and redo a whole bunch of stuff. You can always use tools to create feature classes, and feature class tools are kind of interesting because it allows you to not only select whether you're making a line or a point or what have you. You can also set the coordinate system, and so there's a lot of utility in these tools as well. If you want to add a subtype field, again, it's relatively straightforward as far as the way these properties are set up. You have to set them up before you do stuff, because once you start doing stuff, it's just going to populate it automatically with the things that you put in, and limit what you can put in based on the options you select. You can click on the Subtypes tab and then choose Line Type Field and create the subtype field, and then enter a code and a description for each of the subtypes, so that when you go to your, what is it I'm drawing? Is it a 1, 2, 3, or 4? Is it a water line, a water main, etc.? Defaults are actually where this starts to really become more useful. So you can, for example, if a subtype is a sewer lateral, you can set all the properties for what sewer laterals should be. Now the default's what pops up if you don't change anything. If you know something's different, if something has been made to be different, if you change something, you can change it, okay? But if you don't, then they're all going to be the same. They're all going to have the same diameter. They're all going to have the same pipe material. They're all going to have the same max flow. If all your water mains are 6-inch copper with 700 gallons per minute flow, then you can set up that default, and as soon as you call it a water main, poof, that's the properties it has. Now, if you have a section that has a higher water demand, and so for whatever reason you make that a larger pipe, or if you're out near the edge of the service area and you can't get the adequate water pressure you need off of that 6-inch main, and so you drop it down to a 5, that'll be fine. When you call those sections of those water lines water mains, they're going to pop up as 6s. Those are the ones you'd have to edit and say, no, actually this is a 5. But the default is, it would save you from manually inputting all that information in every one that matches that sort of default description. So defaults are only useful if attributes maintain their value across a great number of the records in a data set. You can set defaults by subtypes. That's important. That way when you load in the right subtype, it gives you the defaults that go along with it. Now each subtype has its own template, or it could. You can choose the design features and add the features are added and the attributes and all that stuff. And you can sort of set all those things up when you create this. And so you're going to create waterline features. You've already went in and set it up that with water lines, they're either sewers or water or whatever. You simply select that property, draw that line. As soon as you draw the line, it's automatically going to be 8-inch copper, 850 gallons per minute, etc. Pretty simple, pretty straightforward. If you got to do a lot of this kind of editing, pretty daggone awesome. Look at all the typing they saved in all of the picture and data that they wasted to just say, see, Mike said it was awesome, and it's really awesome.